Hi, in this lecture you will learn how to create and use the packages. Now we know that to use a package we have two main reasons. The first one is logically grouping the objects and the second one is the performance gain. And we know that professionals choose packages generally because of the performance effects. However, since I am a single user here, I will not be able to show you the performance. But know that packages have a lot of effects on performance when multiple users use the same subprogram. On the other hand, logically grouping the objects is also an important reason, because with this way we can both decrease the code complexity and crowd. Besides, since we gather many objects in one container, we can share these objects amongst each other easier. So you will be able to create more practical codes. So, throughout this course, since I'm a single user, the main reason of using packages will be logically grouping the objects. Great, now let's start how we create the packages. A package consists of two parts: package specification and package body. So a package is divided into two parts. At first, this division seems nonsense, but it is designed for creating public or private objects. You know that Oracle does not have any public or private identifiers. Most of the times we do that with privileges. But in packages, we grant our privilege to the entire package. So if you want to hide some data from the other users while having the privilege of the package, we need to find a solution. To handle this identifier problem, and of course there are some other reasons, you will see them too, Oracle divided a package into two parts. Package specification is for the globalization. That means anyone who has the privilege will be able to use all the objects declared in the package specification. But notice that I said declared. This is important. In the package specification, we only declare our objects. We can declare our functions, procedures, variables, cursors, etc. You know which types of variables can be used in packages already. We cannot type the begin end block of our subprograms, but we can assign some values to the variables. We will see all these. Now, what you declared in the package specification are all considered as public. So anyone can see and use any of these objects. You cannot declare some of them as private. All of them are public. For creating a package specification, it's also called as package spec, we have two main reasons. Either declaring that I will have these subprograms in the package body, or providing some public variables for the others. The second part of a package is the package body. The package body has the implementations of the subprograms declared in the package spec. Actually, a package body can also have its own variables, subprograms, cursors, etc. But here's the thing: if a variable or a subprogram or any other object is not declared in the package spec, it is not visible to the others. Means only the package body can use these objects. So these objects are considered as private objects. On the other hand, a package body can also use the objects declared in the package spec. No problem on that. Alright, now we know that a package body and a package spec are related with each other. So they need to have exactly the same name. But here's the thing: if there is not any subprograms declared in the package spec, so there is no need to create a package body for that package, because you will not be able to use it. The way to reach to the package body is calling the name in the package spec. If the package spec does not refer to any subprogram in the package body, that body is completely useless. So we don't create a body for that. So that means this spec is designed for providing some global objects to the others. Great. Like creating the functions and procedures, we have two ways to create a package: using the SQL Developer tool and using the worksheet directly. So now let's open up the SQL Developer and continue. To create a package with using the SQL Developer tool, we open up the Packages branch here. And right-click and click on New Package option. In this new window, we specify the name of the package and where to create it. I mean the schema name. Actually, we don't have to write them here. We can easily click on OK and change these in this new window. As you know, in Oracle, creating an object via using SQL Developer or by typing does not have any difference. The only difference is you can save some time and type less if you use the SQL Developer tool, because it generates some code for us. In here, there is not so much typed code here, so we can directly type it by ourselves too. Alright, now to create a package spec, as you can see in here, we type create or replace package keywords. Or replace is not mandatory, as you know. Then we write the name of the package and the as or is keyword. But here's the thing. There is no begin keyword in the package spec. But there is an end keyword anyway. Do not forget that. Besides, we can type the name of the package after the end keyword. It's optional. Between the as and end keywords, we write the package declarations as pointed in here by SQL Developer. We write any of our objects here. The order of the object is not so important, but as a programming habit and to increase the readability, we type variables before the subprograms most of the times. Now, let's create a package that has some variables and subprograms, etc. about the employees, and name it with emp, for example. Actually, I suggest you to give meaningful but short names for your packages, because to reach an object in a package, we use its name. We will see that. So shorter names will be much better. But the name must be unique among the other objects. Alright, now let's say that our package spec has a variable, a cursor, a procedure, and a function. Actually, we will expand our package in time, but for now, let's start with these. Now, let's say that our first variable will be a number, salary increase rate. Let's delete here and type the salary increase rate. It's a number and the value is 0.057. As you can see, we have declared our variable and assigned a value for it. It is valid, but we can just declare a variable without the initialization too. It's also accepted. Now we will have a cursor simply selecting from the employees. Cursor, let's say cur amps is select all the columns from employees. And we have a procedure that increases the salaries. I simply write procedure and increase salaries. As you can see, we only typed procedure and our procedure name. We don't have any create or replace keywords here, like we did in our local subprograms. But on the other hand, since this is the declaration, we did not write the begin end block of the procedure. We simply typed the declaration of that subprogram. And notice that since this procedure does not take any parameters, we did not type any parentheses. It's so simple. So now let's create a function then. This time our function will have a parameter too. I simply write function and get avg cell, for example. And our parameter is pdepth id and its type is int. And return number. As you can see, for the functions, we typed function keyword. The name, the parameters, if it has any, and for the last, we write the return type of that function. That's all. All these declarations for functions and procedures are the signatures of these subprograms. The begin end block of these subprograms will be filled in the body of that package. Now let's change the name of the package from here too. Do not forget that. Alright, now we can compile our code then. Great, we could compile our package specification. Now, all these variables, cursors, procedures, and functions are visible to all the others in the database. But since the body is not yet created, anyone who calls the function or procedure will have a runtime error. Because these subprograms are not yet created in the body. But notice that they will have a runtime error, because the compiler checks only the package specs if the specified subprogram is there or not. Alright, now it's time to create the package body. As you guess, there are two ways to create the body again. The first and easier way is using the tool. So we simply right click on the package spec in the connections tab. First, let's refresh here. This is our package specification. We right click in here and click on create body here. As you can see, in a new window, SQL Developer has prepared the signatures of the package spec elements. We need to type exactly the same structure of the functions and procedures. All the names, parameters, and return types must be exactly the same with the spec. As you can see, the SQL Developer did it for us. It also created the cursor declaration too, but it will conflict if we compile like that. So we delete it. It's already declared in the spec. We can use it from there if we wish. By the way, we can have our private variables, types, etc. here. But notice that there is no declare keyword. We type them right after the as keyword. We will see that in the next lecture. Now, let's fill the begin end blocks of our functions and procedures. But before that, let me show you the create code of the package body. As you can see, we type create or replace package body and our package name. We see a new keyword body just after the package keyword. And our name is exactly the same with the package specification. And we have an and keyword at the end, and if you wish, you can write the package name here too. Alright, now let's continue creating our subprograms then. Now for the increased salaries, we loop throughout the entire employees table. So we can use our cursor that we declared in the package spec. So in here, I write for R1 in curAmps loop and our end loop. Now we need to increase the salaries. To do that, we can use our variable that we declared and initialized in the package spec. Let's write update employees copy set salary is equal to salary plus salary times v salary increase rate. Now, it's time to fill our function. We know how to get the average salary in our previous lectures. So first, we need a variable to keep the average value which is returned from the SQL query. Since this is a subprogram, it can have its own variable. So we can easily write avg cell, and it's a number and it's equal to 0. Now let's select the value into that variable. Select avg salary into our new variable vavg salary. From employees copy, and our var clause department ID is equal to pdept ID, and return that variable out. vavg salary. All right, our package body is ready to compile. Let's do it then. Great, now we have our package completely. Now let's see how we use our package. All right, actually we cannot use a package directly. I mean, a package is not a usable thing. It's a container for the objects. So we can use the objects in it. So if you use a function in it, you use it just like how you did in the functions lecture. If you want to use a procedure in it, you do it just like a stored procedure. A variable is also like that. I mean, whatever object in it, you use it like how you use it without the packages. But there is a small difference. To reach an object in a package, we type the name of the package first and a dot sign, like we write the schema name. Because of that, I suggest you to choose short names for the packages. Short but meaningful. So let's start with using our procedures then. I simply write execute amp.increase salaries. And let's run it. Oops, we have a problem here. Value larger than specified precision allowed for this column at line 6. Now let's overcome this problem. Now it says the problem is at line 6. So in line 6 we see that update employees copy set salary. We have a problem in here, I think. So let's change this logic. I simply write salary plus v salary increase, and let's change the v salary increase rate from the package spec. Let's say I add 1 grand for all the employees. Let's compile here and compile the body. All right, now let's come back to our worksheet and run our code again. Oops, we still have a problem, value larger than specified precision. At line 6 again, I think we could not change the salary increase here. So let's delete here and compile again. Now let's run our code then. Clear up and run the code. As you can see, no problem. We used our procedure just like we use the normal stored procedure, but with adding the package name before it. Now let's use our function then. Let's write our begin end keyword, and inside of these let's write our db method. In here I write amp.getAvg salary, and the parameter is 50, for example. Let's run it. As you can see, all the same. Besides, we can use the variables in our package specifications. Let's see it then. Let's copy the dbms output and paste in here and write amp.v salary increase. Let's run it again. As you can see, these are global variables, and I used one of these variables outside of the package. Alright, how you use the package objects is pretty simple. It's like how you use them without a package. Now, let's continue with how you modify a package, because most of the times we will need it. Modification means changing the name, changing the objects in it, etc. Actually, we did these a couple times when we had some problems in here. But for any cases, you need to recompile the packages. But a little different. How? If the change occurs only in the package specification, there are two different scenarios. The first one is if the subprogram declarations change. Now, this time you need to update the package body too, based on the new signature of the subprograms, and recompile both body and the spec. But the package spec must be compiled first. Do not forget, if both package spec and body need to be compiled, the spec must be compiled first. Otherwise, you will have an error. So what if only the variables in the package spec change? This time you need to check the package body too. If these variables are used in that body, and if the name or data type of the body has changed, the body must also be compiled too. But if the changing variables are not used in the body, there is no need to compile the body again. So if the change does not affect the body, there is no need to compile it. Now, if the change occurs in the package body, this time there is no need to compile the spec. Actually, if the change in your package body includes structural change of subprograms, you will also need to change the spec anyway. Alright, so if the change does not affect the other one, there is no need to recompile both. Great, now let's change the name of our package then. Let's name it with amppkg, for example. To do that, we started changing from the package spec, because it also affects the body since they must have the same names. So let's do it and compile. Now we need to change the name next to the AND keyword here. So I write amppkg in here too. And let's compile it again. As you can see, we had a problem because we tried to compile body first. So let's copy our name and change it in our package specification. Let's change all these and clear up and run this code. As you can see, no problem. It is compiled. Now we need to compile the body. As you can see, it is also compiled. Great. Now we changed the name. So let's check them from the Connections tab here. Let's refresh and see our package. But there is a problem here. Our package amp still stays here. That means you cannot change the name of a package. If you do that, you will be created a new package. Be aware of that. So, to drop a package, we can right click on the package name and click on Drop Package. This will drop the entire package. We click on Apply. As you can see, we have dropped our AMP package. But you can also click on the package body and drop the body significantly. Click on here and click on Drop Package Body. You can also drop a package with writing Drop Package Name, and for the body you can type Drop Package Body and the package name. If you drop without the body keyword, you will drop both spec and the body. But if you type Drop Package Body, you will drop only the body. Alright, we can change any of the objects inside of the package. But we need to be aware of the effects on each other. If one of them affects the other, they both must be recompiled. But this time you need to compile the spec first. By the way, sometimes you may use a bodiless package. A bodiless package may seem a bit useless, but not actually. Sometimes we may need a bodiless package to provide some global variables to the others. So let's create one then. This time we will create it by typing. So let's open up a new worksheet and type it. Now, our package will have some variables, types, etc. So let's write create or replace package constants pkg and our is keyword. We can have variables and we can initialize it. We know that. So let's write v salary increase. It's a number and let's say it's 0.04. We can have cursors. Let's say cursor cur amps is select all the columns from employees. And we can have types. TM's type is employees percent row type. And let's add one more variable in it. Let's say v company name varchar2 and the value is, let's say, Oracle. Now let's compile it. As you can see, we have compiled our constants package. We created our package with typing and without the body. Now we can use these variables from any object, program, or platform. The only need is the privilege. We saw how to use them. Alright, in this lecture you saw how to create, modify, and drop a package. In the next lectures we will go into some more details and some more advanced topics. So this is the end of this lecture. See you in the next lectures.